It's a pleasure to stay here with all of you. My name is Karina Flandes, and I am a student of the Instituto Tecnológico de Ciudad Madero in the career of Petroleum Engineering. And I want to tell you about the research that I am developing for my thesis. That is about the carbon capture for the enhanced air recovery with CO2 injection. Currently, we are facing two realities in the oil and gas industry. I'm talking about our country. One is that between 40 to 60% of oil production in Mexico comes from natural fuels. That percentage could improve if the appropriate technology is used to increase extraction percentages. The fields that have begun their period in decline only require greater investment and correct technology to continue producing it. And the other reality includes the commitment in which we are all, and mainly the industries, to be able to reduce significantly the amounts of greenhouse gas emissions, such the CO2 that are in the atmosphere. This before end this century in accordance with the commitment signed in the COP21 in Paris. We are witnessing an amplifying momentum for carbon capture. International Energy Agency and Intergovernmental Panel on Climate Change projections show a dramatic increase in carbon capture across all industries and geographies. Technically, the concept of capturing and storing CO2 underground is well understood. The challenge lies in balancing project frameworks and economic returns. That is, this with economic and environmental benefits too. To make our recovery increases the hydrocarbons productions that can be done with CO2 injection, which currently is the only method that provides economic benefits like produce additional volumes of hydrocarbons and make a large carbon capture emitted by both fossil fuels or biomass power plants that otherwise could be vented to the atmosphere. We note that the enhanced air recovery results from the injection of gaseous, chemical, or the use of thermal energy after carrying out the primary and secondary recovery, since between 55 to 70% of the oil is still in the reservoir, as trapped microdrops in the pores of the reservoir rock. The CO2 injection into the reservoir can mobilize the trapped oil. When the CO2 enters in the reservoir, interacts physically and chemically with it, and with the contained oil, creating favorable conditions that improve the recovery. These conditions increase the reduction of capillary action forces, since they inhibit, that is, repress the flow of oil through the pores of the reservoir, due to the presence of high interfacial tensions between the oil and the rock. Another condition that it creates is the oil expansion, or swelling that is commonly known, which is going to occur for an increase in solubility. The CO2 solubility with the oil depends on its compositions, temperature, and pressure. This reduces the viscosity and the interfacial tensions between the oil and the rock. By increasing the solubility with these factors, the oil swells and increases the relative permeability, improving mobility and at the same time creating a wetter blockage. Another condition that occurs is the oil viscosity decrease, that, as we saw, goes hand in hand with solubility. CO2 has a low viscosity relative to oil. For these reasons, the oil reservoir can contain high viscosities that are not candidates for CO2 miscible displacements. On the contrary, in light crudes, we can get a greater increase in swelling. Okay, another condition that presents and improves the recovery is the interfacial tensions reduction. But what is this about the interfacial tensions? This is the tensions or resistance that will arise when making a break with an external force in order to achieve a mixture. In this case, the CO2 with the oil. In order to achieve this, we have to reduce these interfacial tensions, which will be achieved by increasing the capillary number. Increasing this, the viscous forces will predominate over the interfacial forces that exist in them. Maybe this of the capillary number sounds a little bit confusing, but it is one of the most important factors to consider in the recovery methods, since by increasing it by 3 or 4 orders of magnitude, the recovery can be achieved of almost 100% of oil in the swept zone. Okay, we talk about the reduction of the capillary forces, that are the forces that repress the flow of oil through the pores of the reservoir, and about the reduction of the interfacial tensions to be able to achieve a mixture. And we are going to achieve this too with the increasing of the capillary number. I'm talking about this, of the capillary number. We have another important concept, that is the residual oil saturation reduction, which for any miscible process will have the objective of taking it to the lowest possible value in order to increase the recovery factors, since thanks to miscible mixing of CO2 with the oil, the interfacial tension is reduced to zero practically. It must be remembered that the residual oil saturation is the volume fraction of the oil that remains in the pore at the end of a displacement process for which a specific fluid was used. But well, going back to the general part of the enhanced recovery with CO2, let's talk about the two displacement methods, which are the miscible and immiscible displacements. In miscible displacements, the CO2 injected is mixed completely with the oil in the reservoir, reducing the interfacial tensions between the two substances to almost zero. These forms allow viscosity fluid that can be easily displacements and produced. Recovery is usually in 4 to 12% more. In immiscible displacements, when the reservoir pressure is too low and the oil density is too high, the CO2 injection doesn't mix with the oil inside the reservoir, but causes a swelling oil density reduce, improving mobility and consequently increase the oil recovery. This recovery could achieve 18%. Okay, one of the most used techniques is the oil recovery with CO2 is the Huff and Puff technique, which consists in inject CO2 in gaseous form into the formation. Once the CO2 is inside the formation, the well is closed for a period of time calculated to allow gas-liquid miscibility with the oil from the formation, and then the CO2 reacts with the congenital water to form carbonic acid, which will react with the calcium carbonate from the rock storage, increasing permeability. After a certain time, the wells open in a controlled manner and must manifest an increase in production. Huff and Puff is a successfully process for enhanced recovery tested by various companies in many parts of the world, such as Occidental Elk Hills in California, Ecopetrol in Colombia, Sinopec in China, and Penrong and Arca Energy in Alberta, Canada. Well, we know that the time is short, but at least we talk a little about the CO2 injection process, how it behaves and how the oil recovery is carried out. And I want to tell you that for CO2 capture are different ways in which it's being present through the world. There are industries that use for the enhanced oil recovery or only for capture and inject into the earth in saline aquifers or reservoir depleted. And one of the most incredible examples of this is the Gorgon project on Barrow Island in Australia that is operated by Chevron in joint with Shell and ExxonMobil, in which expects to reduce greenhouse gas emissions from the Gorgon project by approximately 40% or more than 100 million tons over the life of the injection project. Well, with all of this, we conclude that the enhanced recovery is in our country and in a large part of the wells that exist in the world is one of the main activities of the oil industry maintains, and that we can do with one of the most important problems that we have today, that is the CO2 emissions. It's a project with a huge processes and a lot of infrastructure in many aspects, but that is contributing with a sustainable development for our future generations.